The quadratic formula can be used to solve any quadratic equation as long as it's in standard form. That means that all of the like terms have been combined and they're on one side of the equal sign, so that equal 0 is really important. If we call a the coefficient of the squared term, b the coefficient of the linear term, the x term, and c the constant term, then the solutions to the quadratic equation are given by this formula. X equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Here's an example. If we want to find the solutions to this quadratic equation, first we'll notice that it's already in standard form. The a for our quadratic formula will be 2, the b will be negative 5, and the c will be 1. Substituting those values gives us this. Now we just have to be careful about a few signs, and we have to remember that we're using order of operations to simplify. So negative 5 is positive 5, and under the radical, negative 5 squared is negative 5 times negative 5, or positive 25. If we simplify what's under the radical, 25 minus 8 is 17, and we've got our two irrational solutions to the quadratic equation. Let's look at another example. Let's find the solutions to 5x squared plus 2x minus 3 equals 0. This equation's also in standard form, so we're ready to substitute values into the quadratic formula to find the solutions. So our solutions are given by negative 2 plus or minus the square root of 2 squared minus 4 times 5 times negative 3 all over 2 times 5. Now let's simplify. Under the radical, 2 squared is 4, and negative 4 times 5 times negative 3 is positive 60. If we add the 4 and 60 together under the radical, we've got 64. And the square root of 64 is 8, which means we no longer have a square root in our answers. So if we separate that into the two solutions it represents, the negative 2 plus 8 over 10 and the negative 2 minus 8 over 10, we'll be able to simplify each of the fractions to get two rational solutions to our quadratic equation. So as you can see, the quadratic formula is a fail-safe way to find the solutions to a quadratic equation, but it's not always the most efficient. In this case, because we did get rational solutions, that tells us that we could have found the solutions to the quadratic equation by factoring, setting the factors equal to 0, and then solving each equation. That would have been a little quicker, as long as it would have been easy to see how to factor the equation. Now before we leave the quadratic formula, let's do one more thing and actually derive the formula to see where it comes from. We can derive the quadratic formula by completing the square on the equation in standard form. So here we go, let's do it. We'll start by dividing all the terms by a, because to complete the square we need the coefficient of the squared term to be 1. Now we'll subtract c over a from both sides of the equation, so that we can think about what we need to add to both sides of this equation to make the left side a perfect square. To figure that out, we'll look at the b over a, which is the coefficient of the linear term. We'll take that coefficient and divide it by 2, and then we'll take the result and square it. So to complete the square, we need to add b squared divided by 4a squared to both sides of the equation. The left side will now factor into a binomial that's been squared. And while that looks really complicated to do that factoring, it's pretty easy, because that b over 2a that we got when we divided b over a by 2 is the second term in that binomial. On the right side of the equation, we'll just get a common denominator to both fractions so that we can add them and have one fraction. Now we'll use the square root property and take the square root of both sides of the equation, and then simplify both sides. And as one last step, we'll subtract b over 2a from both sides of the equation. And there we have it. That's our quadratic formula. You may never have a reason to derive the quadratic formula, but now you can see where it comes from. If we complete the square on the quadratic equation in standard form, we end up with the quadratic formula.